Hi everyone, welcome back to the channel. Today, we're diving into a foundational concept that powers nearly every modern program you use, and that is what we call concurrency. So whenever you open multiple browser tabs, streams a video while downloading a file, or send several API requests at once, you're actually experiencing concurrency in action. But what exactly is concurrency? So why do developers go through the trouble of designing systems that handle many tasks at the same time? So by the end of this video, you'll understand what concurrency really means, why it's important, and how it helps us make faster programs and more efficient without necessarily making our hardware stronger. So let's start with the why. So imagine you have a program that sends a request to a remote server. The server takes about 1 second to respond. That's actually very short already. So during that 1 second, your program does absolutely nothing. It just waits. So now suppose you would like to send 3 requests one after another. Each take 1 second. That's 3 seconds of total waiting time. So but then here's the key insight. These requests are independent. You don't want them to be dependent because you don't want one request to wait for another request to be finished before the second request would start. The first doesn't need a result of the second or third. Why should we wait for one to finish before starting the next? In this case, concurrency allows us to overlap these waiting periods. While the first request is waiting for a response, the second can already be sent and the third can be prepared. This means that total time might drop from 3 seconds to roughly 1, simply by not being idly. I hope everybody's following. So concurrency, in short, helps us keep the CPU busy instead of letting it sit idle. First thing first, we're going to import some packages. Let's have this one, import time from concurrent that features import thread pool executor. So these 2 lines of Python demonstrate the core idea in practice. Time.sleep represents waiting, so our program in this case is paused as though it's waiting for a slow network or a database. So the thread pool executor represents doing things simultaneously. So instead of one person cooking 3 dishes one after another, just think of it as 3 cooks preparing different dishes at the same time. And that is what we call concurrency. So that means it's not about making one dish cook faster. It's actually about preparing several dishes together so the total meal is ready sooner and you won't get hungry. Now let's have this. This function is a trip to the kitchen. We can think of it as a trip to the kitchen or a call to a remote server. What do we have in here? This function is called network_requests, which simulates a slow task. It pauses for 1 second, then returns a result, which is the square of a number. So each request is slow, but of course independent, perfect for concurrent execution. Now let's have this. Think of this function as a worker that sends a request and prints the answer. So if we run this 3 times in sequence, like fetch square 2, fetch square 3, or even fetch square 4, we are actually trying to force the worker to finish one job before starting the next. So it means that this is sequential processing. This is actually safe, but of course, this one is very slow. So concurrency then lets us give these 3 jobs to 3 separate workers at once. So that means while one waits for a response, others keep working. And how do we do that? Let's have this to show where concurrency happens. So this is where the magic is. So this is the concurrency engine. Thread pool executor creates a pool of workers. So each worker handle one number. They all start together. So instead for one job to finish, all 3 start their network calls almost simultaneously. The total time is about 1 second, not 3, as opposed to just without using concurrency, one worker takes 1. So that means if you're going to have 3 workers, this would take us 3 seconds, but in this case, because they are almost simultaneously, then all of them would just do it in 1 second. We can notice here that the CPU is not actually faster, it's just busier. We've overlapped idle time with useful work. So we have not yet executed each one of them. So let's execute each. All right. And so let's see what we have. What would be the result? So this just simply ensures that our program runs when we execute the script. So it's like flipping the on switch. Without it, our setup would exist but never actually run. So let's see if our code really works. Okay, it's working. Now the result is 4, the result is 9, the result is 16. As you can see, it just finishes in about 1 second. So originally, each task took 1 second, which means all in all would be 3. So with the use of concurrency, all tasks start together and complete almost at the same time. So this demonstrates the essence of concurrency. So it doesn't make individual tasks faster, but it just reduces the time we need to wait for have the result or for the result. So concurrency keeps our system responsive. It also makes it efficient and of course scalable. So if you have a website handling thousands of users or a data pipeline processing multiple files, we can process them almost all together. We can say or instruct our system to do all of these jobs all together, all at the same time. So it's how modern software avoids wasting time and energy while waiting for slow tasks to finish.